know this difference between these two? My spectrum analyzer is going to use one dot, right? And the dot, usually the dot, the colorful dot, is going to be as big as this distance. So if I put one dot in here, one here, you see them with your eye, which is with your eyes, which is a low pass filter. You feel like they are connected. So after a certain increasing, after I keep increasing t, you will see this shape is convex. They're attached to each other. You won't see the difference because it's too small for your spectrum analyzer to show it to you. So you will see a convex range of frequencies are covered. And this is beautiful. It tells you if you have a periodic signal. A periodic signal have many components, many frequencies, which the peer of it, like periodic one, couldn't have them. So going from periodic to aperiodic, let me remove this, to, you should always memorize or know this, that representation in Fourier domain or frequency domain is going to be convex. This is a property. You already saw I use this. I'm going to just make this one line and keep this. So I can use this notation or way of showing and say Ft communicate with F omega. But what it really means that I can go to F omega and I can come back to Ft anytime I like and I want. This is Fourier pair. The rest of this lecture, I'm going to just spend time to talk to you about some of those important signals that we like to look at the pair in frequency domain. And I will go ahead and tell you how to calculate those important pairs. First, I will define them. And then maybe next lecture, I will tell you how to calculate the Fourier transform. Any question here? One extra thing, I guess, before I start introducing a few functions, I may need to do this. Linear time invariant systems, and what we get is white. We know this. If you have a linear system, time invariant, and you have a signal Ft, if you use it as an input, then you get white. And we knew that we can do this. We can go to Fourier representation and use Fn Jn omega 0 t, and then in here it was historic. We could do this. I'm going to tell you if the signal is aperiodic, you can do this. I don't use equal because they're not really equal. So let me write it down in here again. LTI, what I can do is I can send F omega. If this is H omega, it's very simple now, right? F omega, H omega. And you're going to work with this for a long time. It's good to memorize it. You can understand it, right, based on the equations and what's happening here. But if you have F omega goes to H omega, simple. Just multiply them. You have F omega, Y omega, which is the spectrum of the atom. Can I do that with nonlinear system? Can I? Is that yes or not? No? Yes? Yeah, I cannot do it because it's, what I'm really doing is I'm using the superposition. If I have one single component, it goes here, then I have this. And if I have a bunch of them, I can just sum them up, right? I'm using superposition rule. I'm breaking down, decomposing this into the components, and then components going through LTI, whatever is going to happen to them, we don't care. In the output, the whole result, the entire result is only summation of the output for any of these individual components. So I use this integral here and here because this system is linear, time invariant. Otherwise, I could not do it. Okay, if you're in exam, sometimes you saw in non-linear time invariant, and you were asked to do something like this, this is false. I cannot do it. All right, let me just introduce a few functions. This part of the class is not going to be very difficult because it's only a few functions, and you may or may not heard about them. Unit step function. I think this is called also Heaviside function. Yeah. So t bigger than 0, t smaller than. You know this function before? Step function? You know it? Okay. Unit, no, signum, or sine function. Shown by SGN, and it's 2 ut minus 1. The other one is sync function. Have you heard about sync function before?
Yeah, he dropped it. I was like too anxious. So what's going on?
Okay. Sync function is defined as sinus t over t, and sine of t over t. If I want to plot it, any guess what's the value at t equals 0? 1. 1. It's not. And these zeros are important. At the place that sync goes to 0, it's where sine of t is 0, right? And so t should be an integer number multiplied by pi. But the truth is at k equals 0, this t is also 0, and 0 divided by 0, we cannot, it is ambiguous. So instead of, like, this is the only, the limit of t equals 0, this is going to be 0 divided by 0. And you learned already that you should use L'Hopital's rule that says that you can differentiate the top and bottom and then use the limit. And this is going to be 1. That's why we got 1 in here. But any other places that we have pi, or 2 pi, or 3 pi, or 4 pi, this function is 0. The value of the function is said that you did not hear about sync function, right?
No, they have learned about it.
They did, right?
Well, yeah.
Lots.
Briefly.
I just had one person talk, but didn't hear anyone else say. The last one is unit triangle shown as delta, and is defined as otherwise it's 0. Any question here about these functions? We're going to work with this function next lecture, some of them. And there's one thing maybe I just mentioned here is, you know about a step function, for instance. You know why we study a step function? Why it is important for us to study a step function? There is a practical reason. What's that? Digital signals? Yeah, kind of. I don't know if we introduced pulse here or not. Pulse was maybe, okay, did I say unit rectangle? I guess I missed that one. Forgive me, I just forgot that one. Unit rectangular function, which is shown by rect, and it is defined as 1 and 0 if the t is smaller than 1/2, the absolute value of t bigger than 1/2, minus half 1, and this is rect function. This is more related to digital circuits, right? This rect function. But a step function, why we study it? Because anytime you switch your board, you turn on your cell phone, you turn on your TV, turn on any electronic device, you turn it on, it was off before. Time. Okay, you turn it on means that you're sending signal to your device. Before that it was off, so you start. This 0 is a very relative value, right? Time 0 is when you press the button to start your computer. So that's why we study it, because if you have a circuit, let's say a DC connected circuit, and have a bunch of elements here, then there is a switch here. This is the button that you press. You press it, you're here. That's why we study that. And any other signals that you see in here, these functions, there is a reason why we study them. We need them in future. As he mentioned, this guy made very important for digital, high-speed digital circuit designers. It's really important. And you will see in future these two are paired. They're fully paired. Okay, thank you. If there is any question,